Lesson 13 in the unit of forces in motion. This is velocity time graph analysis. Let's say Mr. Sklar is just hanging out in his room waiting for his students to arrive. Well, if he's just standing there, his velocity is equal to 0. So for a whole 10-second interval where he is just standing there, the graph would look like this. His speed is 0. He is not moving for the entire 10 seconds. Now this brings us to the first note that we're going to take down. If your velocity is 0, you are not moving. Mr. Sklar hears a knock at the door, so he starts walking across the classroom at 2 meters per second towards the east. If we were to graph this situation, well, this is 2 meters per second east, and for the entire time period, Mr. Sklar is walking 2 meters per second east. So the graph would be a flat line as he has a constant velocity for the entire 10-second period. Now that takes us to our second note. If your velocity is positive, you are moving forward. Uh-oh, turns out there was no one at the door. Mr. Sklar thought he heard a knock, but then again, he's old. So he walks back to his original location in the opposite direction, doing 2 meters per second west for 10 seconds. Now, if we were to graph that, let's bring that graph up. We said he's doing 2 meters per second west the entire time, which would then be negative 2 meters per second east. So for the entire 10-second interval that Mr. Sklar is walking, he is walking at a constant speed, which is negative 2 meters per second east. And the next note, if your velocity is negative, you are moving backwards. Now here Mr. Sklar is just revving up his shoes and then he's off and he slowly starts to speed up until he hits his maximum speed of 4 meters per second and then he slows to a stop. Now let's do that scenario again, this time with the graph. So Mr. Sklar is revving up his shoes, he's not moving, so he's starting at 0 meters per second, but as he starts to speed up, he is going to speed all the way up to 4 meters per second. Top speed then starts slowing back down to 0 when he comes to a stop. So again, Mr. Sklar is revving up his shoes. He has just learned how to do the moonwalk and he wants to impress everyone. So he starts to go backwards, slowly speeding up to a maximum speed of negative 4 meters per second and then slows back down to a stop. So what would that look like if we graphed it? So we're starting at 0 meters per second, but this time we're going to start going backwards until Mr. Sklar hits a maximum speed of negative 4 meters per second, and then he slows back down to 0 meters per second because he's coming again to a stop. Now let's consider this scenario. Mr. Sklar speeds up and then slows down to a stop and then starts to backpedal and then starts to slow down again and comes to a stop again. So let's graph that. We start off not moving. Then we start to speed up going forward and we continue to go forward but slow down until we come to a stop. Then we start moving backwards till we hit a top speed of minus 4 meters per second. Then we slow back down to a stop. Now, let's complicate this entire thing. If we look back to that initial scenario where I was walking 2 meters per second for 10 seconds and I walked at a constant speed the entire time, well, if we were to darken up the line at 0 and then highlight everything between 0 and the line that was graphed, we wind up with a rectangle. And the area of a rectangle is length times width. And this rectangle has a length of 2 meters per second. because it goes from 0 to 2 on the y-axis. So our length is 2 meters per second. And the width of the rectangle goes all the way from 0 seconds to 10 seconds. So our width is 10 seconds. And 2 meters per second multiplied by 10 seconds gives me 20 meters. Meters per second times seconds, the seconds factor out, leaving me with the unit of meters. And, oh, this is pretty neat. Check this out. If I started at 0, I am now 20 meters from where I started. So, the distance that I have covered equals the area between 0 and what was graphed. Now let's look back to the scenario where Mr. Sklar was walking backwards at a constant speed of minus 2 meters per second for 10 seconds. And this is the graph that was produced. And again, if I darken the line at 0 and then highlight everything between 0 and what had been graphed, I wind up again with a rectangle. And the area of a rectangle we said is length times width. And again, the height of this rectangle is 2 meters per second, and the length of it is 10 seconds. So 2 multiplied by 10 gives me 20 meters. But notice I wrote it in as minus 20 meters because the shape is below 0. Any shape that is below 0 will have a negative value. And if I take a look at how much ground was covered, well, if I started at 0, that would now put me at minus 20 meters. Now let's look at that scenario again where I was not moving, and then I sped up gradually to a top speed of 4 meters per second, and then I started to slow back down until I came to a speed of 0 because I stopped again. Now if I darken that line at 0 and I highlight everything between the graphed line and 0, I wind up with a big triangle. And the area of a triangle is base times height divided by 2. If I look at this triangle, the base is 10 seconds. And the height of the triangle is 4 meters per second. And if I multiply those two numbers and divide by 2, it's 10 multiplied by 4, which is 40, divided by 2, that gives me 20 meters. And guess what? From start to finish, I am now 20 meters from where I started. All right, let's look back to that scenario where I was standing still, and then I started to walk forward until I hit a maximum speed of 4 meters per second. Then I slowed down to a stop. Then I started to speed up in the negative direction to minus 4 meters per second. Then I slowed down again to a stop. If I darken the line at 0 and I highlight everything between 0 and the graph, I wind up with a triangle on the top and a triangle on the bottom. Now, we said the area of a triangle is base times height divided by 2, in which case both these triangles coincidentally happen to have a base of 5 seconds. They also both have a height of 4 meters per second. So 5 multiplied by 4 is 20, divided by 2, the area of each of these triangles is 10 meters. But the triangle on the left is above 0, so it's plus 10 meters, and the triangle on the right is below 0, so it's minus 10 meters. So interestingly enough, notice that I finished where I started, because my displacement is plus 10 subtract 10. But my distance is different because I walked forward 10 meters and then back 10 meters, so that means I walked 20 meters. So my displacement is 0, but my distance covered is 20 meters. Now, let's complicate this entire thing. The first thing I want you to do when you have a VT graph is darken in the line at 0. Then take your highlighter and highlight everything between 0 and the line that has been graphed. Now we take a look at the area that has been shaded and we break it up into nice, neat triangles and rectangles. If I draw a line here and a line here, then I now have 4 triangles and 1 rectangle. So calculating the area should be easy. The first triangle, well, area is base times height divided by 2. And the base of this triangle goes from 0 to 1.5 seconds. So the base is 1.5 seconds. And the height, it goes from -4 all the way up to 0. So it's got a height of 4 meters per second. So 1.5 multiplied by 4 divided by 2, the area of this triangle is then 3 meters. And it is located below 0, so that would be negative 3 meters. The next triangle also has a base of 1.5 seconds because it goes from 1.5 seconds to 3 seconds. It also has a height of 4 meters per second because it goes from 0 up to 4 meters per second. So those are the exact same dimensions. So again, it will be 1.5 multiplied by 4 divided by 2, but this time it's going to be positive 3 meters because this triangle is above 0. Now for that rectangle. The area of a rectangle is length multiplied by width. The length of this rectangle is 3 seconds because we go from 3 to 6 seconds. And the height of this rectangle is 4 meters per second because we go from 0 to 4 meters per second. So the length is 3 seconds multiplied by the width of 4 meters per second, and that gives us a total of 12 meters. And again, it's above 0, so that's positive 12 meters. Now we're looking at another triangle. And like we said, the formula for a triangle is area equals base times height divided by 2. The base this time is 2 seconds because it goes from 6 to 8 seconds. And the height is 4 meters per second because we go from 0 to 4 meters per second. So 2 multiplied by 4 divided by 2, that gives us 4 meters. And that would be positive 4 because this triangle is above 0. Now for the last triangle. The base is 2 seconds because it goes from 8 to 10 seconds. And the height is 4 meters per second because it goes from -4 to 0. And those are the exact same calculations again. So 2 multiplied by 4 divided by 2 gives us 4 meters. And we will write down negative 4 meters because this triangle is below 0. So now we are asked, what is the distance covered over the time period and what is the displacement over the time period? Well, we're going to use the exact same areas. The only difference is that direction doesn't matter when we're calculating distance. So for distance, it's going to be 3 meters plus 3 meters plus 12 meters plus 4 meters plus 4 meters, which equals then 26.0 meters. When we're talking about displacement over the time period, we will have to take into account the direction. So displacement will equal -3 plus 3 plus 12 plus 4 subtract 4, which will give us 12.0 meters. And it is a positive answer, so that is in the north direction, because the graph is set up so that north is the positive direction. Part 3, what is the acceleration at 8 seconds? On a VT graph, acceleration is equal to slope, which is rise over run. So at 8 seconds, we are here on the graph, and that point is on this line. So we're taking the slope of that entire line. The rise of that line is equal to 8 meters per second because it goes from -4 all the way up to +4. And the run of that line is equal to 4 seconds because we're going from 6 seconds to 10 seconds. So rise over run equals 8 meters per second divided by 4 seconds. 8 divided by 4 is equal to 2. So my answer is 2.00 meters per second squared south. Now, how did I get the unit of meters per second squared? Well, my rise is measured in meters per second, and my run is measured in seconds. So meters per second divided by seconds, which then becomes meters per second multiplied by 1 over seconds. So I wind up with 1m on the top and an s squared on the bottom. So further proof that slope on a VT graph is equal to acceleration. Now, how did I get the direction south in my final answer? Well, that's because the slope is negative. And this graph has been set up so that north is positive. So if north is positive and the slope is negative, that means at this time we are accelerating in the south direction. I start by darkening up the line at 0 and then taking my highlighter and highlighting everything between 0 and the line that has been graphed. I'm then going to try to break those shapes up into nice neat triangles and rectangles. So if I cut across there and here, that gives me 2 triangles and a rectangle. And that top part, I'll just change that into a triangle and a rectangle. Now I need to calculate the area of each shape. The first shape I'll do is this rectangle. So that's length times width. Now the length is 8 seconds because I'm going from 0 to 8 seconds. And the width is 3 meters per second because it goes from -3 to 0. So 8 multiplied by 3 gives me 24. So I will write that shape in as -24 meters. Again, negative because this shape is below 0. Now I have that triangle I want to look at, and that's base times height divided by 2. Base of this triangle is equal to 4 seconds because it goes from 4 to 8 seconds. And the height is equal to 3 meters per second because it goes from -6 to -3. So 4 multiplied by 3 divided by 2 gives me 6 meters. And again, this shape is below 0, so I write it in as -6 meters. Now the next triangle. The base is 4 seconds because it goes from 8 to 12 seconds. The height is 6 meters per second because it goes from -6 to 0 meters per second. So 4 multiplied by 6 divided by 2 gives me 12. And once again, it's below 0, so I will write the distance as -12 meters. Now this triangle, it's up on top. Its base is 2 seconds because it goes from 12 to 14 seconds. Its height is 3 meters per second because it goes from 0 to 3 meters per second. So 2 multiplied by 3 divided by 2 because it's a triangle, that gives us 3 meters. And this shape is above 0, so it's positive 3 meters. And lastly, the rectangle up on top. The length is 6 seconds because it goes from 14 to 20 seconds. And the height is 3 meters per second because it goes from 0 to 3 meters per second. 6 multiplied by 3 gives me 18, so that's positive 18 meters. What is the distance covered over the time period? Well, I just add up all those areas as positives. So I went 24 meters, plus 6 meters, plus 12 meters, plus 3 meters, plus 18 meters, and that gives me a total distance covered of 63.0 meters. Now for displacement, I have to take into account direction. So my displacement equals -24, subtract 6, subtract 12, plus 3, plus 18. And that gives me -21.0 meters in the positive direction, or I could have written it as 21.0 meters in the negative direction, because I went backwards more than I went forwards. And lastly, what is our speed and velocity at 6 seconds? So at 6 seconds, we're right here on the graph, and speed is over on this axis. So if I extrapolate over, I see that I am at -4.5 meters per second when I am at 6 seconds on the graph. So my speed is 4.50 meters per second, and my velocity is -4.50 meters per second in the positive direction. Remember that velocity needs a direction where speed does not. So recap, acceleration is the slope of the line at that time. On a VT graph, distance is the addition of all the areas of the graph that are found between 0 and the graphed line. And displacement, well, we have to find all the areas of the graph that are between 0 and the graphed line. Then we subtract those that are below 0 from those that are above 0. And that's the end of the assignment. Make sure that you check often to see if you're getting the right answers. And if you are not, make sure you ask why or find out why your answer is different than what we're finding in the answer key.